Woohoo, we are live. This is Math 40, Elementary Algebra. And these problems that we're doing are in section 7.2. We're learning to multiply and divide using rational expressions. And I copied over the instructions. This is divide and simplify. Before it was multiply and simplify. And so with division, remember, we've got one extra step. When we're dividing, I'm going to rewrite it so that we multiply the reciprocal of the second fraction. So we write it as multiplication, and then we flip the second one upside down. And then once it's multiplication, we multiply across. So 20y times 5y squared all over 9z to the 7th times 6z to the 4th. Now, if you don't see anything, it's okay to go ahead and just multiply. I think I've got 100y cubed all over 9 times 6 is 54z to the 7th plus 4 is 11th. And then I say, oh no, oh my goodness, you guys were probably yelling at the screen the whole time. I can divide both of those by 2. 2 into 100 goes 50. 2 into 54, you got it, is 27. Then I think, okay, 50 is 2 times 25, so it's some 2s, some 5s. 27 is all 3s. That's it. That's all that will reduce. So I get 50 y cubed over 27 z to the 11th. Woohoo! Shall we do another one? Of course. This one's a little bit more exciting. I mean, that's a lot more exciting. So I've got x minus 6 all over the opposite of 6 minus x. I'm going to write it as times x plus 1 all over 3x minus 18. Okay. So now what? Well, we've got a couple options. But what I think I'm going to do is I'm going to try to factor what I can. So let's see, I've got x minus 6 and x plus 1. Down here in the denominator, 3x minus 18, 3 times the quantity x minus 6. And then this one is hard to read. So what I'm going to do is I'm going to rewrite it as the opposite of x minus 6. So I changed the order right there. So, okay. So far, I see that the x minus 6 and the x minus 6 are going to cancel, but I don't know what else. So, x minus 6 times x plus 1 all over. Now here I could factor out a minus 1. Minus 1 out of x is, out of the opposite of x is x. Out of the opposite of 6 is plus 6. Okay, so we've got it written like that. Okay, so now I'm going to take a look. Were these opposite polynomials? The answer is no. This was x minus 6. The minus was on the 6. This has the minus on the x and the minus on the 6. That's too much. So I can reduce the x minus 6's. Anything else match exactly? Nope. So then I think I'm getting x plus 1 on top, and the opposite of 1, x plus 6 times 3. I'm going to write the minus out in front. This minus is going to come out in front. X plus 1 on top, and then 3x plus 6 in the denominator, or x plus 1 over 3x plus 18. As I said, depending on your instructor and WebAssign and all the other things, you may be able to leave it the denominator factored, or they may want you to multiply it out. 3 times x is 3x, 3 times 6 is 18. Okay, but either way, we're done. Woohoo! Okay, that page is down. I've got one more division problem, and it's a bit of a doozy. Dun, dun, dun! First thing I'm going to do is I'm going to write it as multiplication. Because to do anything else for me is just too dangerous. What I'm going to end up doing here is using a lot of paper. I gave myself the whole paper. I know, you guys are proud of me. I appreciate that. And I'm going to factor everything. So for example, y squared minus 36, y plus 6, y minus 6. Difference of squares. So difference of two squares on top. This one's going to be a little bit more complicated, so I'm going to leave that till last. This one looks not too hard, so let me do that one. I'm going to factor out a 3, and I'm left with y minus 6. Okay. And now this one's going to be trial and error. I've got a y and a y. And I got to think of two numbers that multiply to negative 12 but add to negative 1. How about negative 4 and 3? And then this, believe it or not, this is a perfect square. I don't know if you recognize it. It's y, oops, not plus. Uh-oh. Where's my magic? Look, it's a pterodactyl. Don't look. So I got to say, that doesn't work. Oh no, it's broken. That doesn't work as well when we're not in the classroom. Normally when I say that, I point out the window and I try to get everyone to look out the window instead of looking at my mistake. So look, it's pterodactyl. Y minus 4, y minus 4. Okay. So let me pull out some colors here because we're going to need them. So for example, I've got a y minus 6 right here, a y minus 6 down there. As long as I'm multiplying, I'm allowed to cancel things top to bottom. Let's see, what else do I have? I have a y minus 4 here and a y minus 4 there. Those will cancel. Not sure anyone else cancels, so I'm going to go ahead and cancel these two, cancel those two, and I get y plus 6 times y plus 3 all over y minus 4 times 3. First thing I'm going to do, change this order. Make this 3 times y minus 4. Okay. Now, in my class, you could leave it like this. But for WebAssign and for other people's classes, sometimes they want you to multiply it out. If that's the case, let's multiply. This will be FOIL, y squared plus 3y plus 6y plus 18 all over 3y minus 12, y squared plus 9y plus 18 all over 3y minus 12. We did it. You're brilliant. Woohoo. Okay, so next up, the last thing in this section is we're going to talk about something kind of weird. It's a weird application of multiplication of fractions, multiplication of rational expressions, and that is converting units. So let's take a look at this. One use of rational expressions is converting units of measurement. You may have heard the following riddle. When is 24 equal to 1? The answer is when 24 hours equals 1 day, right? So we can convert from hours to days. So this is what we mean by conversion. We can write this equation, 24 hours equals 1 day, in terms of a rational expression, 24 hours to 1 day. By the way, this is called a ratio. Whenever you've got a single fraction, you can consider it a ratio, but it's especially a ratio when you're comparing two amounts. So 24 hours per 1 day is 24 over 1 hours per day, right? Or 24 hours per day. If you've ever wondered what per means, per divided by, right? Percent is divided by 100. We can use this to help us convert. For example, let's use the following facts to convert from miles to inches. So I went and looked these things up. There are 5,280 feet in a mile. There are 12 inches in a foot. You probably knew the second one. Even you might have known the first one. If I'd like to know how many inches there are in a mile, I write inches per mile, and then I do something interesting. I know inches per foot, right? And if I multiply by feet per mile, notice that the feet cancel. And all I'm left with is inches on top and miles on the bottom. Inches per mile. Inches per foot is 12 to 1. Feet per mile is 5280 over 1. So I multiply and got 63,360 inches per mile. And if you've ever gone running, and if you're like me, you don't like running. I'm not a big fan of running. So whenever I'm running, I can tell you there are probably more than 63,000 inches. I've felt every single one of those. So for my example, I would like to use this technique to compute how many seconds there are in a year. So I want seconds per year. Okay. Now, personally, I know how many seconds there are in a minute. Okay. That's 60 seconds in 1 minute. Then I need to come up with minutes. Minute. So we start with the next one I start with has to match this. So this has to go there. I know minutes per hour. That's 60 minutes in an hour. Right? So the minutes are going to cancel now. This is good. And now I need to start with hours. Now, I don't know how many hours there are in a year, but I know how many hours there are in a day. That's 24 to 1, right? And then I'm going to be able to cancel the hours. And then days, I need to start with days. Now, what do I know days to? I know days in a month, but that's not going to help me. I want to get years. Do I know days for year? Yeah, I do. Although it's a little tricksy because it depends on the year. When I am recording this is 2020, and it's a leap year. And so there are actually more days this year than most. But most of the time it's 365. So let me just use 365. If you want, you could do 365.25, right? And a quarter. Okay. So do you see how I've used the fact that denominators and numerators cancel, and all I have left now, this didn't go all the way through, is seconds per year from setting up this string of multiplication. Okay, this is going to be 60 times 60 times 24 times 365. And I get, wow, that's a big number. 315360000. Okay. 31,536,000 seconds in a year. Ooh, that would make a good song. Well, there's an idea, but 7.2 is done. Math on, you guys. You did it. You got through 7.2. Next up, not so fun, 7.3 and 7.4. We're going to be adding and subtracting fractions. I recommend you do the homework for 7.1 and 7.2 first. Make sure it's solid. Make sure you understand what's going on. And then come back and look at the 7.3 and 7.4 videos. Woohoo. Rock on, guys. You're so brilliant. You're so smart. And I miss you terribly. Take care. Bye-bye. Woohoo. Rock on. Math on. Woohoo.